So, in the previous screencast, we talked about matter, and matter is anything that has mass and takes up space. And so, one of the things that we're going to investigate in this class is the properties of matter. So, when we talk about properties here, these are the characteristics of matter. Scientists use to categorize different types of matter. So, when we talk about properties, particularly of matter, we are going to talk about chemical properties and physical properties. And so that's how we'll describe matter a lot of times, is by these chemical and physical properties. Now, there are other ways to categorize matter. We can categorize matter by state, right? Is something a solid, a liquid, or a gas, right? And then we can also categorize it by composition. Right? Is it homogeneous? Is it heterogeneous? Is it an element? Is it a compound? So let's talk more about properties, and then we're going to talk about the ways to classify matter. So this is the overview of everything we're going to talk about in this particular screencast. So let's talk about physical and chemical properties. So a physical property is observed without changing the composition or identity of a substance. Right? So, for example, these could be things like color, right? It could be the density. It could be ductility of a metal, right? Which is the ability to stretch a metal into a wire, which we're going to talk about a lot when we get to our metal chapter. Now, we also need to talk about physical changes. A physical change produces a recognizable difference in the appearance of a substance without causing any change in its composition or identity. So this, for example, would be like what we see here, which is an ice cube melting. When you have ice, it is H2O, it is water, it is frozen, right? And when it melts, it is still water, it is still H2O, but the ice looks a lot different than liquid water. So we see there's a recognizable difference in the appearance. Ice looks different than water, but there is no change in its composition or identity. So it's still water, it's still H2O, whether it is liquid water or whether it is frozen, right, and ice. Now let's talk about chemical properties. These result in a change in composition and can be observed through a chemical reaction. And so when we talk about these would be things like flammability. the ability of something to catch on fire, right? And we can see a Bunsen burner right here. It is on fire, and what is happening there is that's the propane that is on fire. So the ability of propane to burn, that flammability, that ability to burn, is a chemical property. Now, when it is burning, that is a chemical change. Another word for a chemical change, or phrase for a chemical change, is a chemical reaction. Right? And in this, a chemical substance is converted into one or more different substances by rearranging atoms. So when we have a Bunsen burner and propane is burning there, the chemical formula for propane is C3H8, and it reacts with oxygen gas, which is O2. And it forms carbon dioxide and water as vapor, right? And so when we talk about this is a chemical reaction. And when you look here on the left side, these are our reactants. And then on the right side here, these are our products. And we'll talk more about chemical reactions later in the class. But chemical reactions are the ways that we describe the chemical change, or how these atoms are rearranged. Now, let's talk a little bit about the states of matter. When we talk about states of matter, there are three big ones that you've probably been exposed to quite a bit. Solids, liquids, and gases. Solids, when we talk about solids, we abbreviate solids with an S, and generally we put parentheses around it. Now, when we talk about solids have a definite shape and volume. When we think about it on an atomic level, so this is an example of a thermal feature at, say, Yellowstone, where we've got the solid ice here, we have liquid water here, and then we have vapor here. So when we think about the molecules of water that are in a solid, they are locked into place. So the atoms or the molecules are locked into place. And they can vibrate, and they do vibrate back and forth, but they don't move freely. Now, liquids are the next thing we're going to talk about. You can see the liquids right here. In liquids, these have a definite volume. We can measure the volume of a liquid, but the liquid will take the shape of its container. And so what we say is there is no definite shape. And here, the atoms are in close proximity. But they can move past each other. Then the last phase that we're going to talk about in the screencast is gas. So when we talk about gas, this is vapors. A lot of times it's represented with a G. I forgot to tell you that the liquids are represented with an L, right? So we've got gases here. Gases have neither a definite shape or volume. They expand to fill their containers. And there's a lot of space between the atoms. Okay, so we can say, hey, look, those particles of gas are really far apart. Okay. Now, because those particles are really far apart, that means gases can be compressed. So that's why you can buy compressed gases in a, like in a can, in a store, anything like that. And it's important to know that the gases can be compressed, but solids and liquids can't be compressed. Okay, so that is a big difference there. Now, we are also in class going to talk about plasma, but we'll cover that in class. Now, when there's a transformation from one state to another, that is called a phase change or a state change. And we are going to talk about that more in class. So, a transformation from one state to another, that is a phase change or state change. And those are just synonyms for one another. Now, let's talk about the other way that we can classify matter, which is by composition. When we talk about the composition of matter, we can divide it into two different categories. We can say, hey, look, it's a pure substance, and that's a substance with only one component. Or we can say, hey, look, it's a mixture. And this is a combination of two or more pure substances. And each of these retains its own identity. Right? And it's important to notice that these are mixed together, but they're not undergoing any chemical reaction. So let's talk about pure substances just a little bit. There are two types of pure substances that you're going to run into. One is an element. Now, when we talk about the element, the kind of definition of an element, it is a pure substance that cannot be separated. Into simpler substances. Right? An easy way to identify an element, though, is it's just something that's found on the periodic table. Okay, so this would be something like gold, oxygen, sulfur, something on the periodic table. Now you can have a compound, and this is a pure substance that's composed of two or more elements that are bonded together in fixed proportions, right? They can be broken into the individual elements by chemical reactions. So an example here would be water. Water is H2O, right? It's composed of two or more elements. They are bonded together. We can run electricity through water and break it apart into hydrogen gas and oxygen gas. Water is a compound. Now, I want to talk a little bit more about elements and how we identify them, and then a little bit more about compounds. So first, I said, hey, look, we've got these elements and we can identify them using a periodic table. I want to talk a little bit about just periodic table 101. When we look at the periodic table, right, you're going to see that the vast majority of the periodic table are metals. So the metals are located here on the left-hand side. They are this tan color. You're going to see here on the right-hand side that we have our non-metals. They are this green color. And then we have here in purple our metalloids, and a step-like divide here gives us the metals from the non-metals. We have, later we're going to talk about the properties of metals and non-metals and metalloids, but it's just really helpful to be able to recognize them. These are your elements. So these are our pure substances that are elements. When we look at the periodic table, it's broken up into, you can look at it using periods. Periods are the horizontal rows that go like this. You can also look at groups. Groups are the vertical rows like this. Groups contain elements with similar properties. So there's periodic table 101, but the big take-home message here is, hey, look, these are our elements. If you're trying to classify a pure substance and it is an element, it is going to be on the periodic table. Let's talk about compounds. When compounds pop up, we're going to see things that look like this. I used water as an example. When you have a subscript that comes after an element, that tells the number of atoms. So we can say, hey, look, we've got 2 atoms of hydrogen. There is no subscript after oxygen, so we have a 1 there, and that's just understood. And there's 1 atom of oxygen. Sometimes you're going to see parentheses like this. And what you do is you take this number and you multiply it by whatever the subscript is within the parentheses. So if we are looking at the number of calcium atoms, there's just 1 calcium atom. But there are 2 oxygen atoms. And 2 hydrogen atoms. Now, we can also have mixtures. When we talk about mixtures, we have 2 different types. So a mixture, right, is just a combination of 2 or more pure substances. And we can have a homogeneous mixture where you have a uniform distribution through the sample. With no visible boundaries. Right? These can also be called solutions. So that's another word for homogeneous mixtures. A really good example is vinegar here. Vinegar is a mixture of acetic acid and water. Okay. You can also have, so when we talk about mixtures here, they can be in any phase. So vinegar is an example of an aqueous mixture, but you can have a solid mixture. So for example, bronze is what we call an alloy. And that is a mixture of copper and tin. So it's a mixture of copper and tin. So if you see the word alloy, that generally means you've got a mixture and it's homogeneous. That's one of the ways that we describe metals. Now, you can also have a heterogeneous mixture, and here the components are not uniformly distributed, right? They have distinct regions. Of different compositions. So a good example of this is the salad dressing. Concrete is another example because that's made up of sand, right, gravel, and mortar. We can see all those kind of different pieces. It's not uniform. Granite is another example. If you've got granite countertops, you can see kind of different flakes and pieces. It's not a uniform mixture there. So in summary, right, when we talk about our classes of matter, right, if it can be separated by a physical process, it is generally a mixture, okay? If it is just an element or just a compound, it is a pure substance. Elements we find on the periodic table. Compounds are two or more different elements that are held together by chemical bonds. When we talk about mixtures, if it's uniform throughout, it's homogeneous. If it is not uniform throughout, if it's got visibly distinguishable parts, it's heterogeneous.